We'll now take some time to look at making a graph or table in order to solve problems. Recall that the make a graph or table strategy has a general idea of summarizing data about a large population by creating a useful visualization that illuminates key trends. How do we do this? Well, we understand the data that we're given and the measurement methods that were used to generate the data. And then we analyze the data in any number of ways depending on what we're trying to accomplish with our data analysis. Now, prior to this lesson, we've been very explicit about Poy's problem-solving process. And by now, it's probably becoming second nature. So in this video, the problem-solving process will kind of be in the background. And this video gives an example of how this problem-solving process is in place even when there's not a specific objective in mind. Sometimes you just want to explore some data to see if there's something interesting going on. So let's take a look at some data. Here you're given the data on exam scores for 25 students in a statistics class. Take a look, for example, and see what you can discern. The answer is probably not very much. You can see from the headings that you have been given the previous algebra score of the student, so a score that that student got in a previous algebra class, as well as their present statistics exam score. But we see a large jumble of scores here, and it's really hard to see if there's any kind of trend that stands out or anything interesting going on. So this is a time when we want to use Excel. Excel, as we know, is a useful tool for organizing data, storing a small amount of data, and analyzing it in a variety of different ways. And so one of the first things we're going to do is just paste this data into Excel, and we're going to sort it from smallest to largest based on previous algebra scores. So we use this sort function up here, and we sort the pairs of data according to previous algebra score. And we can already see some trends about our data set that weren't evident from the disorganized list of data that we had at first. We can see we have some very low algebra scores in the 60s, a few in the 70s, and then most of the scores, we know there are 25. We can't see the whole list here, but we see that all but 7 are in the 80s or 90s. So most of the scores are in the 80s or 90s. In fact, it looks like 11 of them are in the 90s. And we also see a general trend that the statistics exam scores seem to basically be higher for students with higher algebra scores. So you see low stat exam scores are associated with lower algebra scores, and so on. So we already have some information just by sorting the data. But we may want to take a good look at the real distribution we have here. So in order to do that, we're going to create a column chart. And creating a column chart, we just go to this column chart function in Excel. We click on it, and we can click any number of different column types. There are a bunch listed. We just want the basic clustered column that allows us to compare values across categories by using vertical rectangles. And you can see there's even a description of what each chart helps you to do. We use this when the order of the categories is not important for displaying the item counts, such as a histogram. So we'll create that chart. And we can't just do that based on the raw data. We have to organize the data somewhat. So we organize it into two columns, stat exam score, as well as the number of students that fall into that range. And we organize our buckets by decile. So we have a bucket that is 10 points wide, so 41 to 50, 51 to 60, and so on, and then the number of students with each score. We plot this, and we can see kind of what we suspected, that most scores for the stat exams are clustered on the high end, as with the algebra scores. Now, to make this a proper histogram, we're going to make some changes. We always, with a histogram, want the columns to be lined up right next to each other snugly with no gaps. And we can do things to format to make our chart look the way we want it to. So we can put, for example, the legend at the bottom. You can also see you can put in grid lines, make changes to axes, and even add a data table that shows this data here in the bottom of the chart so that you can easily copy and paste among functions. So we've got a sense of our distribution. We look back. We can get a sense that most of our data is clustered on the upper range. We can also count the number of students that fall into each bucket. And we could generally say that this data distribution is skewed toward the high end. Now, what if we wanted to take a look at how algebra scores and statistics exam scores are correlated? We had previously observed that there seemed to be a positive correlation, so that they were increasing together. And to verify this, we can create a scatter plot. So to do this, we click the scatter plot type, and we see that the scatter plot allows us to compare pairs of values. So we create this plot, and this is the way it looks when we initially create it. So we may want to make some changes to the plot in order to get a better sense of what it looks like. We may want to change, for example, from having these sort of small diamond shape markers, we want to may want to change the markers to a different size or different color. We also can change the axes. So we saw the axes on the previous chart, if we look, were very kind of compressed our data set. We didn't actually have any data down here from 0 through 40. So in the next iteration, we change our axes so that the minimum is around 50, and we change our vertical axes in the same way so that we don't have as much white space. And then we can clearly see that we do have this positive correlation that we were talking about. The next step can be to add a trend line. So this trend line gives us the what's called a regression line. It tells us approximately the best estimate for how, on average, the score in a previous algebra class could predict the statistics exam score. And in this case, we highlighted some outliers, some numbers that seem very unusual. This would be a good way to find out, where maybe something some variable makes a big difference. For example, this student had a really high score in his previous algebra class, but his statistics exam score was much lower than would be expected based on that. So we could look at what happened with this student, and this could be a very useful data point to study. Now, another thing that we may want to look at is beyond just taking a peek at the exam scores, we may want to look not just at the raw numbers, but at the proportion of a class that has a particular exam score. Because, for example, saying 2 students out of a class of 25 is perhaps a little bit difficult to communicate to people and have them really understand what it means, rather than saying 8%. So in order to do this, we could highlight the data that we want to manipulate. Now we know that there are 25 students in the class, and what we do is we just highlight the cell that we're interested in making a calculation on and divide by the sum of all of the other values in the histogram. We know that these values sum to the total number of students. This is the number of students in a category. And then we can perform a calculation that allows us to calculate the proportion for each category of student across the whole class. So we can see that indeed only 16% of students were in this really low 40 to 60 range, 24% were in the 60 to 80 range, and then 60% of the students were kind of from 80 to 100, which might be considered an acceptable educational standard. And if we wanted to quickly translate this information to a table that we could copy and paste, we can do that by right-clicking and selecting Create a Table, and then we simply select the data, and voila, a table is produced that we can easily copy and paste into other applications. Similarly, we could combine these two pieces of information if we wanted to do a report out and really look back. So we showed a lot of information just in a table and a chart. In the table, we show the general trend in the class to being higher. We show approximately where most of the students fell, but we also show the trend based on the previous algebra score with the stat exam score. So we're sort of reporting on the present as well as reporting on an important relationship, showing how that relationship is quantified and how we can make predictions with it, and showing some of the outliers, which give it a sign of what the variability is. So we have a sense of mean and median or central tendency, a sense of variability, and a sense of a very important relationship. So as you can see, some basic manipulation in Excel, as well as some basic manipulation with data visualization, can give us a lot of information and be a very powerful tool for us as we're trying to communicate information